A fan can lose useful performance before the air reaches the wheel.
A sharp plate opening, a poorly matched inlet ring, or distorted approach flow can make the impeller ingest a contracted, separated, uneven stream. An inlet cone is a small component, but its job is precise: guide air into the fan eye with a geometry that matches the wheel and the installed boundary.
The result must be judged at the complete fan duty point, not from the part alone. First, define the names.
A Bellmouth or inlet cone is a rounded entry that turns and accelerates air toward a fan inlet.
An inlet ring can also establish the mounting and wheel interface dimensions.
A true Venturi has a converging section, a defined throat, and normally a diffuser. With calibrated pressure taps it can be used for flow measurement. These shapes are related, but calling every rounded ring a Venturi hides important geometry and test requirements.
Now compare a sharp-edged opening with a rounded entry. At a sharp edge, streamlines cannot always follow the abrupt turn.
The jet contracts downstream of the opening, a separated recirculation zone forms near the wall, and the usable flow area becomes smaller than the physical hole.
The resulting velocity profile can be non-uniform before it reaches the wheel. This is a mechanism illustration, not a universal loss coefficient.
A properly sized inlet radius can make the turn more gradual. Streamlines may remain attached, the contracted jet can be reduced, and the fan eye can receive a fuller velocity profile.
But larger is not automatically better.
The radius, entry diameter, cone height, area change, surface condition, and available installation space must work together.
A smooth-looking part can still be mismatched to the wheel.
The cone-to-wheel interface deserves its own drawing.
Check inlet diameter, impeller eye diameter, axial insertion or setback, radial clearance, concentricity, and runout. Too much gap can allow recirculation and leakage. Too much insertion can obstruct the eye or interact with rotating geometry.
The correct relationship is model-specific and must include manufacturing tolerance, assembly movement, and service access.
Keep the energy account honest. A passive inlet cone does not add total pressure.
It can reduce avoidable inlet loss and deliver a more usable flow feel to the impeller.
Static pressure, velocity pressure, and total pressure must not be mixed.
A true Venturi measurement uses the pressure difference between defined stations and a calibrated coefficient. A decorative throat without taps and calibration is not a flowmeter.
The upstream system can defeat a good cone.
A guard, filter, coil, wall, elbow, damper, cable bundle, or blocked panel placed too close to the inlet can create swirl and an uneven velocity field.
One quadrant of the wheel may then work differently from another. The review must include approach distance, free area, obstruction pattern, leakage path, and the exact installed orientation, not only the inlet ring drawing. Operating point changes the answer.
At different flow rates, the inlet velocity, incidence at the impeller eye, separation risk, sound, and system resistance all change. Reynolds number, air density, speed, diameter, and surface condition affect how a scale geometry behaves. An inlet that helps one fan near one duty point cannot be assigned the same benefit across every size, speed, and system curve.
A defensible comparison changes only the inlet geometry.
Use the same fan, impeller, motor, and control, hold rotational speed and air density, preserve the same guard, duct, and test boundary, and document every clearance. Measure volume flow, name static or total pressure, electrical input, speed, sound, vibration, and temperature. Repeat points in both directions so drift and hysteresis are visible.
Read the results as a coupled system.
A new inlet can move the operating point even if motor speed is unchanged, so comparing watts at two different flow rates can be misleading.
Plot the full pressure flow and power flow curves, calculate efficiency with one declared pressure definition, and show measurement uncertainty and repeatability.
A single free air point or 1% without its boundary is not enough.
Real hardware keeps this discussion grounded.
Longwell product photographs show the formed radius, flange, circular opening, and mounting holes of an inlet cone.
The RLM drawings show that entry diameter, outer diameter, height, hole count, and pattern change with model size.
These files prove visible construction and dimensional interfaces only, they do not prove a pressure, efficiency, noise, or certification result.
For procurement, release the inlet as an aerodynamic interface, not a generic accessory.
Specify the naming convention, section profile, material and surface, entry and wheel diameters, radius or contour, height, axial position, clearance, concentricity, runout, hole pattern, upstream free area, guard and duct arrangement, and the match test method. Validate the complete fan across its required envelope.
For an OEM inlet interface review, contact Longwell.